Hey everyone, welcome back to the channel. In this video, I will walk you through how to install Fedora 42 Workstation with snapshot and rollback support using BTRFS, Snapper, and a few essential tools. This setup gives you a powerful safety net, allowing you to undo system breaking changes and restore your system to a previous working state quickly and easily. And here's what I will cover in this video. Okay, I've got the ISO downloaded and the bootable installer ready. So let's move on and start installing Fedora 42 with snapshot and rollback support. Boot your computer using the Fedora Workstation 42 installer in UEFI mode. On the welcome screen, click on the Install Fedora button to proceed. You will now see the new Anaconda Web UI, which introduces a more modern and streamlined installation process. This new installer is currently exclusive to Fedora Workstation 42 only. Select your preferred language and keyboard layout. In this tutorial, I will go with the default settings. Click Next to continue. On the installation method screen, you will need to configure how Fedora will be installed. This includes selecting your disk and setting up partitions. Make sure the correct installation disk is selected under the destination section. For example, in this demo, I'm using a 128 GB virtual disk, which shows up as VDA corresponding to /dev/VDA. You might notice it listed as 137 GB instead of 128 GB. That's because the installer shows disk sizes in gigabytes, while Linux typically uses gigabytes, and 128 gigabytes roughly equals 137 gigabytes. If the disk shown isn't the one you want to install Fedora on, click Change Destination and choose the correct one. Since I'm running this in a virtual machine with only one disk, it automatically selects /dev/VDA. If you have multiple disks, they'll all be listed here. Just select the one you want to use and click Select. Since mine is already correct, I'll just hit Cancel to return to the main screen. By default, the installer suggests use entire disk, but since we need a custom layout, we'll bypass this. Instead, click the three-dot menu in the top right corner and select Launch Storage Editor. A warning will pop up letting you know that the storage editor is an advanced tool and that any changes you make here are applied immediately. Don't worry, just click Launch Storage Editor to continue. Inside the storage editor, we'll first create a new partition table. This will erase all existing partitions, so exercise caution if you're dual booting or have important data on the selected disk. Since I'm working with a blank disk, I'll proceed by selecting Create Partition Table. Click on Initialize to confirm, and a new GPT partition table will be created. Next, we need to create the required partitions. Click the three-dot menu, then select Create Partition. We'll start by creating the EFI system partition. Set the size to 1.074 gigabytes, which is approximately 1 GB bytes. Even though the installer shows sizes in GB, Linux tools and file systems typically work in GIB. Set the type to EFI system partition. The mount point will be added automatically as /boot/EFI. I'll label this partition as ESP, though you can name it anything you like. Now click Create to finalize it. Next, we'll create the BTRFS partition using the remaining free space. Again, go to the three-dot menu and choose Create Partition. I will allocate all the remaining disk space to the BTRFS partition. This time, set the file system type to BTRFS. Leave the mount point field empty. Label the volume as Fedora or anything you prefer. Then click Create. I won't create a separate boot partition. Instead, I want the kernel and initram-fs to reside inside the btrfs root subvolume. This way, when I perform a rollback, the kernel and initram-fs are also rolled back automatically. This prevents mismatches between the system files and the boot components, avoiding potential boot failures after a rollback. Also, there's no need to create a separate swap partition. Fedora automatically enables swap on ZRAM at boot. ZRAM creates a compressed block device in memory and uses it for swap, providing faster swap performance compared to traditional disk-based swap. It reduces input-output operations to the disk, improves responsiveness on low memory systems, and the swap space is dynamically created at boot and destroyed at shutdown. Now that we've created both required partitions, the EFI system partition and the BTRFS partition, we'll move on to creating subvolumes within the BTRFS volume. To do this, click the three-dot menu on the line labeled Top Level under the BTRFS section and choose Create Subvolume. When setting up a system with snapshot and rollback support, it's important to create separate subvolumes for certain directories. This allows you to control what gets included or excluded during a snapshot and rollback. For example, you typically want to roll back system files, but not user data, logs, or cache files, which change frequently and could cause problems if rolled back. Isolating these directories into separate subvolumes helps maintain system stability and integrity during rollbacks. First, I'll create a subvolume for the root file system. This is where Fedora itself will be installed. It's the main subvolume, and it will be snapshot-enabled so we can roll back the entire system if needed. I'll name this subvolume root and set its mount point as /, which represents the root of the file system. Next, I'll create a subvolume for home. This directory contains user data, personal files, and user-specific configuration files. By separating home, you can preserve your personal data even when rolling back the system. This subvolume will also be snapshot-enabled. I'll name this subvolume home and mount it at /home. Next, I'll create a subvolume for OPT. This directory is often used for installing third-party applications and software that are not managed by the system package manager. Separating /opt ensures that if you roll back the system, your manually installed software remains unaffected. Now, I'll create a subvolume for cache. This directory stores cache files, such as downloaded packages and temporary data. Since cache data is constantly changing and not critical for a system rollback, isolating /var/cache prevents it from cluttering snapshots with unnecessary data. Next, I'll create a subvolume for GDM. This directory contains important files used by the GNOME Display Manager. Without separating it, Fedora Workstation can hang or fail to reach the login screen when booting into a read-only snapshot. Creating a separate subvolume here ensures smooth operation even when working with snapshots. Now, I'll create a subvolume for libvirt. If you use KVM virtualization, this directory holds your virtual machines and their settings. Separating it ensures that VM files remain stable and are not unintentionally reverted or corrupted during a system rollback. Next, I'll create a subvolume for log. Logs are frequently written and updated, and including them in snapshots could cause conflicts or fill up snapshot space quickly. By isolating /var/log, we avoid unnecessary snapshot bloat and potential issues when rolling back. Now I'll create a subvolume for spool. This directory is used by various services for temporary storage, like print queues and mail spools. Similar to logs, these files are transient and should not be rolled back with the system, so it's best to keep them separate. Finally, I'll create a subvolume for TMP. This directory holds temporary files that may persist across reboots, but are not critical. Keeping /var/tmp separate ensures that temporary files don't interfere with system snapshots and rollbacks. We've finished creating all the partitions and subvolumes needed for installing Fedora with snapshot and rollback support. Now click the Return to Installation button to head back to the main installation screen. If everything was set up correctly, you should see a green check mark indicating a valid storage layout. Now press continue. Click Next to review your installation summary. And finally, click the Install button to start the Fedora installation. The installation of Fedora Workstation 42 will now begin. The installation is now complete. Click the Exit to Live Desktop button, then restart your system. The last phase of the installation process will start. Complete the remaining setup steps, like creating a user account, setting a password, and configuring any additional options. After completing the setup, you'll be logged into Fedora Workstation 42, featuring the brand new GNOME 48 desktop environment. Now open the terminal. I will increase the font size so the text is easier to read. I will also switch to a bright color scheme to improve visibility. The first thing I'll do is change the host name of the system. I am setting it to Fedora, but feel free to set it to whatever you like. After changing the host name, close the terminal and reopen it to make sure the new host name is applied. As you can see, the host name has been updated successfully. By default, Fedora enables a feature called the hidden grub menu. Since we're setting up Fedora with snapshot and rollback support, we want the grub menu to always be visible. This way, we can easily boot into snapshots when needed. So let's disable the hidden grub menu feature. Here you can see that menu auto hide is currently enabled. I will go ahead and disable it. Now, if we check again, you can see that the menu auto hide feature has been successfully disabled. Next, let's inspect the BTRFS file system setup. This command displays information about your mounted BTRFS file systems, including the device path, label, UUID, and total size. It's a good way to confirm that your root file system is using BTRFS as intended. Now, let's check the layout of your disk and partitions by running this command. You should see something similar to this. Finally, let's list the BTRFS subvolumes to confirm the setup. You should see output like this. Each subvolume helps isolate different parts of the system, making snapshots and rollbacks more flexible. The last subvolume, var/lib/machines, is automatically created by systemd. It's used for managing lightweight containers through tools like systemd and spawn or portable services. Even if you're not using containers now, having a separate subvolume for this directory improves system organization and makes future container management much easier. Now, let's update the system to ensure everything is up to date. The update is now complete. Now, reboot your machine to apply all changes. To make sure important user data is preserved when rolling back Snapper snapshots of the home subvolume, it's a good practice to move certain application directories into their own dedicated BTRFS subvolumes. This way, they won't be affected by Snapper's undo change or rollback operations. As an example, I'm going to create a separate BTRFS subvolume for Firefox's configuration directory .mozilla. This ensures that Firefox settings, bookmarks, and other user data are protected from rollbacks affecting the main home subvolume. However, since the .mozilla directory already exists, I can't simply create a new subvolume with the same name. To work around this, I'll first rename the existing directory. Now that the original .mozilla directory has been renamed, I can safely create a new subvolume. Let's check to confirm that the new .mozilla directory has been created. You'll notice that the newly created .mozilla subvolume is owned by the root user. Since we want it to be owned by the currently logged in user, we'll need to fix the ownership. Run this command to recursively change ownership of all files and directories inside your home directory, including hidden ones. Now, let's verify that the ownership of .mozilla has been updated. Next, I'll copy the contents of the old .mozilla directory into the new .mozilla sub volume. Now that all the files have been copied, it's safe to delete the old directory. Since we modified the file system structure, it's a good idea to restore SELinux contexts, especially if you are running Fedora with SELinux enabled. Finally, let's list all BTRFS subvolumes to confirm that .mozilla now exists as its own subvolume. In this demo, I've only created a subvolume for .mozilla to show you the basic steps. Depending on your workflow and needs, you might want to create additional subvolumes for other important application directories. Here's a table with some common examples you may want to consider. Creating separate subvolumes for these directories can help protect critical configuration and security-related data during system rollbacks. Next, let's enable snapshot and rollback support on Fedora. To set up a robust snapshot and rollback system, we will first install a few important packages. Now, let's set up automatic snapshot creation through DNF. Snapper integrates with DNF using a custom actions file. This file tells DNF to automatically create snapshots before and after any package operations like installs or upgrades. To create this actions file, paste this code into your terminal. I will include the code in the description and on my website for easy copy pasting. Press enter to apply it. Once done, verify that the file was created correctly. Next, we need to create Snapper configurations for the root and home file systems. First, create the configuration for root. This command tells Snapper to start managing snapshots for the system root directory. Then, create the configuration for your home directory. This sets up Snapper to manage snapshots for your personal files in /home. Confirm that both configurations have been successfully created. Next, we need to restore the correct SE Linux context for the .snapshots directories. This ensures that SE Linux labels are properly applied, which is important for system security and Snapper's functionality. Verify that the SE Linux labels are set correctly. Next, we'll grant the user access to Snapper and sync the file ACLs for both the root and home configurations. This allows your user account to manage snapshots without needing root privileges and ensures file permissions are handled correctly. First, I'll configure it for the root volume. Then I'll apply the same settings to the home volume. Next, list the subvolumes. You will now see new .snapshots subvolumes created for root and home. Before moving forward, let's optimize system performance. We need to prevent the system indexer from scanning the .snapshots directories. So open the configuration file. And add this line. Save and exit. Now list the root snapshots. Then list the home snapshots. At this point, no snapshots exist yet. They'll be created automatically when you install, update, or remove packages, or when you create them manually. Now let's install and configure grub-btrfs. This tool allows Grub to detect and list your BTRFS snapshots at boot, letting you boot into a previous system state if needed. First, clone the repository. Change into the directory. Open the config file for editing. We need to apply a few Fedora specific adjustments. Uncomment this line. This enables overlay FS support, allowing snapshots to boot into a temporary overlay layer. Uncomment this line. Fedora stores grub files in grub2, not grub, so this change is needed. Then uncomment this line. Again, Fedora uses grub2 to regenerate grub menus. And finally, uncomment this line. This ensures grub script syntax is validated correctly when updating the grub configuration in Fedora. Save and exit the editor. Now install grub-btrfs. You might see a no snapshots found message. That's normal because we haven't created any snapshots yet. Next, enable and start the grub-btrfs monitoring service. This daemon watches for new snapshots and updates the grub boot menu automatically when needed. Your grub-btrfs setup is now finished. You can now safely remove the cloned directory. And with that, your system is now fully set up for snapshot and rollback support. Snapper is now ready to manage your system and home snapshots, and Grub will automatically detect them, allowing easy restoration if anything goes wrong. Your system is now snapshot ready. Now that everything is set up, you can enable automatic timeline snapshots. With this feature enabled, Snapper automatically creates a snapshot every hour. And once a day, the timeline cleanup algorithm removes older snapshots based on your configuration settings. By default, timeline snapshots are enabled for both the root and home configurations. However, it's recommended to keep it enabled only for the root and disable it for the home volume to avoid excessive snapshot clutter. So enable timeline snapshots. This timer schedules periodic snapshots of your file system, allowing you to roll back to previous states if needed. Similarly, enable cleanup timer. That's it. From now on, Snapper will automatically create one snapshot every hour and clean them up daily according to the timeline settings. As you can see, a new timeline snapshot for the system root has been automatically generated after an hour. To showcase Snapper's capabilities and highlight how useful it can be in real-world scenarios, I ran a series of practical tests. I strongly recommend trying out these tests yourself. They'll give you a much clearer idea of how Snapper can help you recover from system-breaking changes like misconfigured updates or accidental deletions. I will include the link in the description. And that brings us to the end of this guide. If you found this helpful, drop a like and let me know your thoughts in the comments below. Thanks for watching, and I'll catch you in the next video. Until then, take care, stay curious, and happy exploring.